as I continue, I have this example. Find the Taylor polynomial, so we don't know it necessarily if it's centered at 0, of degree n equals 6 for f of x equals natural log x at c equals 1. So what I would do, my 6th degree Taylor polynomial would be f of 1 plus f prime of 1 times x minus 1 to the 1 divided by 1 factorial plus f double prime of 1 times x minus 1 squared divided by 2 factorial plus f triple prime of 1 x minus 1 cubed divided by 3 factorial plus f the fourth derivative evaluated at 1 times x minus 1 to the 4 divided by 4 factorial plus my fifth derivative evaluated at 1 times x minus 1 to the 5th divided by 5 factorial plus my sixth derivative evaluated at 1 times x minus 1 to the 6th divided by 6 factorial. So that's what we would be doing. Well, I need to calculate derivatives, so I'm going to erase that. F of 1 is equal to 0, right? F prime of x is equal to 1 divided by x. So f prime of 1 is equal to 1. F double prime of x is equal to negative 1 divided by x squared. So f double prime of 1 is equal to negative 1. F triple prime of x is equal to 2 divided by x to the third. So f triple prime of 1 is equal to 2. The fourth derivative of my function f is going to be negative 2 times 3, 6, divided by x to the 4. So the fourth derivative evaluated at 1 is going to be negative 6. My fifth derivative of x is going to be a positive 24 divided by x to the 5th. My sixth, and therefore my fifth derivative evaluated at 1 is going to be positive 24. My sixth derivative evaluated at x is going to be negative 120 divided by x to the 6th. My sixth derivative evaluated at 1 is that negative 120. So let's get our Taylor P going here. My P sub 6 of x is going to be 0 plus f prime of 1, which is 1, times x minus 1 to the 1 divided by 1 factorial, plus this negative 1 times x minus 1 squared divided by 2 factorial, plus, and then my next term, the third derivative evaluated at 1 is 2, so I have 2 times x minus 1 to the third divided by 3 factorial, plus, and then the fourth derivative is this minus 6 times x minus 1 to the 4th divided by 4 factorial, plus 24 times x minus 1 to the 5th divided by 5 factorial, minus, or plus a negative 120 x minus 1 to the 6th divided by 6 factorial. Now, we don't have to clean this up, but what's beautiful is the patterns that emerge. I get this x minus 1 minus the quantity x minus 1 squared divided by 2, plus that 2 divided by 3 factorial is just going to be x minus 1 to the third divided by 3, minus that's going to be 24 divided by 6, last time I checked was at 4, so you've got minus x minus 1 to the 4 divided by 4, plus, and then do you see what's happening here? You're going to have a 5, x minus 1 to the 5th, and then minus, and you just have a 6 here, and this x minus 1 to the 6th. Again, you don't have to clean it up, but man, that is tight. So that's the 6th degree Taylor polynomial for the function f of x centered at c equals 1. Now, we're going to use our calculators. We're going to plug that in as our function, and we're going to use our calculators to find polynomial approximations. We're going to find we're going to find p sub 6 of 1.8. I plug that long function into my calculator and I get 0.570112. I actually find the natural log of 1.8 and I get 0.587787. Therefore, my error is 0.017675. I guess that natural log function isn't as special as that sine function because our error is larger when we're using a degree polynomial that's even greater. Very, very interesting. On part C, the problem asks you to, on your TID9, under the F3 menu, on your TID9, they want you to let y1 equal natural log x and y2 be your Taylor P. So I'm going to do that, and Nancy gives you some great ways to do that on the note sheet, and I'm just going to let you do that. But if I plot natural log x, and then I go to plot this Taylor, I can do a Taylor polynomial. There's a Taylor option of natural log x, comma, and then we're going to do a 6th degree polynomial, and it's going to be centered around 1. If you don't enter a 4th argument, the computer's going to assume that you're centering it at 0. But look at this. Boom. That pink curve looks quite a bit like natural log x early on. So that's what you're doing with this assignment.